where's my mouse? Over here. It can't really compress and disappear. Like you can't squeeze it and just like, oh, okay, just kind of squeezes into itself like you would do a foam. The sealant does this. So as you compress it, it tries to pop out, right? And then the opposite is as I try to stretch it, then it elongates. This one is elongated, right? So this one is going to try and kind of do this, and you'll notice that it kind of gets thinner in the middle as it gets longer. So again, it can't create more of itself, and it can't disappear itself. So if you compress it, it has to go somewhere, and if you stretch it out, you know, it has to make room to be able to stretch that way.
Yeah, delta L is the coefficient of thermal expansion times the length times the difference in temperature.
So if this dam member expands 1/8 of an inch, what happens to my sealant? It's going to shrink 1/8 of an inch, right? Now what happens if this slab deflects another 1/4 of an inch? Now I'm moving in both directions against that sealant. So now I'm really compressing it. And original sealant, this is it under extension, this is it under compression, and again here this is the original and this is it under shear. Give me 1 second. Easy to stretch. Like I can literally go my full screen in this case, right? And then if I hold it shorter, then I really can't. I'm trying, and it feels like it's about to break. And it's the same rubber band. It's not becoming more flexible or less flexible. I'm assuming, I don't know the answer to this, but I'm assuming there's just less material for it to actually displace and stretch like this. Versus here, I've got the full length of the what's it called. So remember 15% of joint width. So assume that you have a 1/4 inch joint. Everybody on their phones do 15% of a 1/4 inch. How much is that? Exactly. Nothing.